In this video, we are going to talk about how to integrate rational functions by the method of completion of squares. So, the general problems that we'll be talking about come in this form. That is integral of du over a squared plus u squared. And this integral is equal to 1 over a tan inverse of u over a plus c. And then this integral, which is integral of du over square root of a squared minus u squared, is equal to sine inverse of u divided by a plus c. And then the integral of du over u square root of u squared minus a squared, this one too is 1 over a sec inverse of the absolute value of u divided by a plus c. So these are generally the nature of the integrals that we'll be talking about. It still falls under the antiderivatives of rational functions. Remember that we have already said that if, for example, you integrate a function which is like this, f prime of x divided by f of x dx, what we said is that if you have a rational function such that if you differentiate the denominator and you get the numerator, then the integral is equal to the natural log of the absolute value of the denominator, then plus c. However, there are some cases that when you differentiate, you are not going to get exactly the numerator, but you are going to get some constant times the numerator, which is different from the derivative of the denominator. So in those kind of cases, what do we do? For example, let's take integral of 3x plus 1 divided by x squared plus 2x dx. You see that when you differentiate x squared, you will get 2x, and when you differentiate 2x, you will get 2. So the derivative of the denominator in this case is 2x plus 2, which is different from 3x plus 1. So the way to do this is by first saying that this 3x plus 1 is equal to a certain constant lambda times the derivative of the denominator, which is x squared plus 2x, plus another constant mu. So 3x plus 1 is equal to lambda times, if you differentiate x squared, you get 2x, and if you differentiate 2x, you get 2 plus a constant mu. So we can then expand this and find the constant lambda and mu. So 3x plus 1 is equal to 2 lambda x plus 2 lambda plus mu. So what it means is that, see, the coefficient of x here is 2 lambda and the coefficient of x here is 3. So 2 lambda is equal to 3, and therefore lambda is equal to 3 over 2. And then we also know that 2 lambda plus mu, this is mu, equals 1. But we know that lambda is 3 over 2, so 2 times 3 over 2 plus mu is equal to 1. So this can cancel out, and therefore we get mu to be equal to 1 minus 3, which is minus 2. So what it means is that this integral, which is integral of 3x plus 1 divided by x squared plus 2x, can be written as equal to, there's a dx here, integral of, we said lambda, and then lambda is 3 over 2, so 3 over 2 times the derivative of the denominator, and when we did the derivative, we got 2x plus 2, and then plus mu, but mu is minus 2, so minus 2, all of this divided by the denominator, which is x squared plus 2x dx. So let's continue further. So having gotten this, what we can do is that we can break this integral into 2 by saying that this is equal to 3 over 2 integral of 2x plus 2 divided by x squared plus 2x, then minus 2 integral of 1 divided by x squared plus 2x dx. So this function, sorry, there's a dx here. So this integral is now in a form that we can easily integrate. Let's also talk about integrals of the form. For example, integrals now of the form integral of f prime of x divided by square root of f of x. Now, how do we go about this integral? So let's take an example, like let's say, sorry, this is dx. So let's say integral of 1 over square root of x dx. So this is equal to integral of x exponent minus half dx. So if we add 1 to minus half, we will get half. So this is equal to 1 divided by 1 over 2, then x exponent 1 over 2 plus c. So this is the same as 2 root x plus c. Anytime we integrate a function which is of this form, then you are going to get 2 times the square root of the denominator. It is similar to what we did initially here, where you get natural log of the absolute value of the denominator. Here it is 2 times the square root of the denominator. So these are very important information that we must take notice as we proceed on this tangent. So let's take some examples and solve. Integrate x plus 2 divided by the square root of 1 plus 2x minus 2x squared dx. Now, when we differentiate 2x, the denominator, we are going to get 2 minus 4x, which is different from x plus 2. So it means that we are supposed to express this in a form that is similar to what we did previously. So it means that, sorry, x plus 2 is equal to a certain constant, lambda, times the derivative, so d dx, of the denominator, which is 1 plus 2x minus 2x squared, then plus a certain constant, mu. So x plus 2 is equal to lambda. If you differentiate 1 is 0. If you differentiate 2x is 2. Then if you differentiate minus 2x squared, it is minus 4x. Then plus mu. So x plus 2 is equal to 2 lambda minus 4 lambda x plus mu. So you see that there is an x here, there is an x here. It means that minus 4 lambda is equal to 1. And therefore lambda is equal to minus 1 over 4. But we also know that 2 lambda plus mu is equal to this constant 2. But lambda is minus 1 over 4. So 2 times minus 1 over 4 plus mu is equal to 2. So this is, so minus 1 over 2 plus mu is equal to 2. So mu is equal to 2 plus 1 over, 2 plus 1 over 2. And therefore mu is equal to 5 over 2. We've gotten the values for lambda and mu. It means that this function can be expressed as integral of, now, lambda times d dx of the denominator, and lambda is minus 1 over 4. So minus 1 over 4 times 2 minus 4x, and then plus mu, and mu is 5 over 2. So plus 5 over 2 divided by the square root of 1 plus 2x minus 2x squared. Now, let's proceed further. So what we will do in this case is that we can break this integral into 2. So this integral becomes minus 1 over 4 integral of 2 minus 4x divided by square root of 1 plus 2x minus 2x squared, and then plus 5 over 2 integral, there is a dx here, and plus 5 over 2, there's also dx here, 5 over 2 integral of 1 divided by the square root of 1 plus 2x minus 2x squared dx. We can solve this part. We know the result for this part. but this is where we don't know the result. You can see that this part looks like here, which is du over square root of a squared minus u squared. So what we need to do is that we need to express this to look like square root integral of square root of du divided by u squared, sorry, a squared minus u squared. So this is what we are supposed to do, but we can only do this if we first complete the squares for this denominator. So let's take this function, which is 1 plus 2x minus 2x squared. Let's complete the squares. So the first step is to factorize, make the coefficient of x squared 1. So that is to factorize minus 2 out. And if you factorize minus 2 out, we're left with x squared minus x, then plus 1 over 2. The next thing, find half of x, which is minus 1 over 2. And then we square it, add and subtract. So here becomes minus 2 times x squared minus x. Then half of minus x is minus 1 over 2. If we square it, we'll get 1 over 4. So plus 1 over 4, then plus 1 over 2 minus 1 over 4. Now plus 1 over 4 minus 1 over 4 is 0. So in essence, we've done nothing to the function. So minus 2 then times all of this can be written as x minus 1 over 2 squared. And then minus 1 over 2 minus 1 over 4 is minus 3 over 4. So if you compute this, you get minus 3 over 4. So if we multiply through by minus 2, then we are going to get this to be equal to 3 over 2 minus 2 times x minus 1 over 2 all squared. So what it means is that this integral can become minus 1 over 4 integral of 2 minus 4x divided by square root of 1 plus 2x minus 2x squared dx, and then plus 5 over 2 integral of 1 divided by square root of, now we are going to replace all of this by 3 over 2 minus 2 times x minus 1 over 2 squared. Now you can see that this looks like a certain a squared minus u squared. However, we need to make this coefficient, which is the coefficient of the x minus 1 over 2 squared, 1. And in that way, we need to factorize out the 2. So we need to pull out 2. And if we do that, this becomes minus 1 over 4 integral of 2 minus 4x divided by square root of 1 plus 2x minus 2x squared, then dx, then plus 5 over 2. If we pull out 2, because of the square root, here will be 2 root 2. And then integral of 1 divided by square root of, now because we pulled out 2, here will now be left with 3 over 4. And minus into bracket x minus 1 over 2 squared dx. So you see that this looks in this form, and then we said that this result is equal to sine inverse of u over a plus c. However, so what we need to do is to say, so we are only evaluating this side, and after we combine everything. So let me do that here. We are talking about integral of 1 over square root of 3 over 4 minus x minus 1 over 2 all squared dx. So let's let u to be equal to x minus 1 over 2. So du in this case is equal to dx. And so it means that this, all of this integral can be reduced to, this is equal to integral of du over square root of, now this is supposed to be a squared, So if we have 3 over 4, then 3 over 4 is the same as square root of 3 over 2 all squared minus u squared, because we said u is x minus 2. So minus u squared. And all of this will give us, so in this case, our a is the root 3 over 2. And therefore, this is equal to sine inverse of u. And u is x minus 1 over 2. All of this divided by a. Our a is square root of 3 divided by 2. Now, if we further simplify this, this is equal to sine inverse of 2 times x is 2x minus 1. So 2x minus 1 divided by 2. Then times 2 divided by root 3. So this 2 and this 2 can cancel out. So at the end of the day, our answer is sine inverse of 2x minus 1 over root 3. So what it means is that this integral becomes minus 1 over 4. Then if you integrate all of this, you get 2. Remember we said it is 2 times the square root of the denominator, which is 1 plus 2x minus 2x squared. So we are done with that part. Then plus 5 over 2 root 2. And then if we do all of this integral, that's what we did down here. And that is sine inverse of 2x minus 1 over root 3 plus c. So if we further simplify this, see that these 2 can cancel one of this, so that we're left with 1 over 2. And that will give us minus 1 over 2 square root of 1 plus 2x minus 2x squared, and plus 5 over 2 root 2, and sine inverse of into bracket 2x minus 1 divided by root 3 plus c. So we have another question here, which is integral of dx divided by x squared minus 6x plus 13. So the way to go about this is to first complete the squares. So let's complete the squares for x squared minus 6x plus 13. So in this case, what we do is that this becomes x squared minus 6x. And we find half of the coefficient of x. Half of minus 6 is minus 3. So when we square it, minus 3 squared is 9. So here we'll add 9, then plus 13, and we subtract 9. So all of this can be written as x minus 3 all squared. And then 13 minus 9 is 4. So plus 4. It means that this integral becomes integral of dx divided by into bracket x minus 3 all squared plus 4. See that this integral is of this form, which is du, integral of du over a squared plus u squared. And that is 1 over a tan inverse of u over a plus c. You know that integral of du over a squared plus u squared is equal to tan inverse of u over a plus c. So what it means is that let's let u to be equal to x minus 3. So u is equal to x minus 3. So du is equal to dx. And then in this case, a is equal to 2 because it's supposed to be a squared. So a squared. So a is equal to 2. And therefore, this integral can further be reduced to dx is du. So du over into bracket u squared, because x minus 3 is u, and plus a is 2 squared. And therefore, this is, sorry, there is a mistake I made here. It is 1 over a. So there is supposed to be 1 over a here. So this is a mistake. Let's kindly correct this. This 1 over a. So this is equal to 1 over a. And a is 2. Tan inverse of u but we said that u is equal to x minus 3. So x minus 3 divided by a is 2 plus c. So that is the answer. Now let's solve this problem too, which is integral of x plus 5 divided by x squared plus 8x plus 22 dx. If you look at this rational function carefully, you see that when you differentiate x squared, you get 2x. When you differentiate 8x, you get 8. But the numerator is x plus 5. So that means we need to find the appropriate constant. And we do that by saying that x plus 5 is equal to lambda times the derivative of the denominator, which is x squared plus 8x plus 22, and then plus another constant, mu. So x plus 5 is equal to lambda. If you differentiate x squared, is 2x. If you differentiate 8x, you get 8. If you differentiate 22, is 0 plus mu. So x plus 5 is equal to 2 lambda x plus 8 lambda plus mu. So what it means is that 2 lambda is equal to 1, and therefore lambda is equal to 1 over 2. But we know that 8 lambda plus mu is equal to 5 in this case. So lambda is equal to 1 over 2. So 8 times 1 over 2 plus mu is equal to 5. So 4 plus mu is equal to 5. Therefore, mu is equal to 1. So this integral can be reduced to integral of lambda. Lambda is 1 over 2. So 1 over 2 times the derivative, which is 2x plus 8. Then plus mu. Mu is 1 divided by x squared plus 8x plus 22. So let's break this integral into 2. So this becomes half of integral of 2x plus 8. Sorry, there's the x here. Sorry. Divided by x squared plus 8x plus 22. And then plus, there's a 1 here, which is the same as dx. So integral of dx divided by x squared plus 8x plus 22. And let's continue from the top. So we are talking about half of integral of 2x plus 8 divided by x squared plus 8x plus 22. Then plus integral of dx divided by x squared plus 8x plus 22. Now, we know the answer for this integral, but we don't know the answer for this. So what we need to do is to complete the squares for x squared plus 8x plus 22. Now, so the way to complete this is x squared plus 8x. Then we find half of the coefficient of x, which is 4. Then we square it. 4 squared is 16, so plus 16 and plus 22. Then we subtract 16 from it. So this becomes x plus 4 all squared will give us all of this. 22 minus 16 is 6. So here is plus 6. So what it means is that all of this can be reduced to half of integral of 2x plus 8 divided by x squared plus 8x plus 22, then plus integral of dx divided by x plus 4 squared. Then now, this 6, I'm going to write it as plus square root of 6 squared because it is a squared. So from here, we can see that u is equal to x plus 4. And then a is equal to square root of 6. And then du is equal to dx. So it means that this integral can be reduced to 1 over 2 integral of 2x plus 8 divided by x squared. Sorry, there's dx here. And there is another one to here. X squared plus 8x plus 22 dx. And then plus integral of du, because dx is equal to du, divided by u squared plus root 6 all squared. And then remember that we have already said that integral of du over u squared plus a squared is equal to 1 over a tan inverse of u over a. So in this case, now we know the result for this. This is 1 over 2 natural log of x squared plus 8x plus 22, and then plus this one is 1 over a, so 1 over the square root of 6, and then tan inverse of u, and u we said was x plus 4. We said u is x plus 4, so x plus 4 over a is square root of 6 plus c. So this is the final answer. Integrate 2x plus 3 divided by square root of x squared plus 2x plus 5 dx. So if you differentiate x squared, you see that we get 2x. Now if you differentiate 2x, we will get 3. So if you differentiate 2x, we will get 2, which is different from 3. So what we will say is that 2x plus 3 is equal to lambda d dx of the denominator, which is x squared plus 2x plus 5, then plus mu. So 2x plus 3 is equal to lambda. Now if you differentiate this, you get 2x. Differentiate 2x, you get plus 2, then plus mu. So 2x plus 3 is equal to 2 lambda x, then plus 2 lambda plus mu. So this means that 2 lambda is equal to 2, so lambda is equal to 1, or 2 lambda plus mu is equal to 3. So 2 times 1 plus mu is equal to 3, and therefore mu is equal to 1. So lambda is equal to 1 and then mu is equal to 1. So it means that this integral becomes integral of lambda, which is 1, times the derivative. This becomes 2x plus 2, and divided by square root of x squared plus 2x plus 5 dx. We can now break this integral into 2. So this becomes integral of 2x plus 2 divided by the square root of x squared plus 2x plus 5, and then plus integral of dx over square root of x squared plus 2x plus 5. Now we know the result for this integral. We can easily do this. This is the one that we cannot easily do. So let's write that one here and do it. Then after we will write the whole results. So we are looking for integral of dx over square root of x squared plus 2x plus 5. So let's complete the squares for x squared plus 2x plus 5. Now this becomes x squared plus 2x, then half of 2 is 1, 1 squared is 1, plus 1, then plus 5 minus 1. So this becomes x plus 1 all squared, then plus 4. So this integral becomes integral of dx divided by x plus 1 all squared, then plus, I want to write the 4 as 2 squared. Now from here we can see that u is equal to x plus 1, so du is equal to dx, and a is equal to 2. So this integral can further be reduced. So let me do it here. So this is equal to integral of du over u squared plus 2 squared, and this integral, square root, there's a square root here. So integral of du divided by square root of u squared plus 2 squared will give us the hyperbolic function. So this is equal to the hyperbolic sine inverse of u over a. So it means that this integral is equal to, now if we integrate this, it is 2 root x squared plus 2x plus 5 and plus 4 hyperbolic sine inverse of u is x plus 1. So x plus 1 divided by a, which is 2. So plus c. This is the answer for the integral. Sorry, I made a mistake in the writing. Mu is not 4. Mu is 1. Because mu is 1, there's not supposed to be 4 here. So therefore, it is just 2 square root of x squared plus 2x plus 5 and plus hyperbolic sine inverse of x plus 1 over 2 and plus c. So we have this question here, which is to evaluate the integral of dx divided by x squared plus 2x plus 2 all squared. Now, what we need to do is to complete the squares for the denominator, which is x squared plus 2x plus 2. So this becomes x squared plus 2x. Then half of the coefficient of x is 1. 1 squared is 1, so plus 1. And here becomes plus 2 minus 1. So all of this can be written as x plus 1 all squared, then plus 1. So this integral becomes integral of dx divided by, into brackets, x plus 1 all squared plus 1 all squared. You see that 1 plus tan squared theta is sec squared theta. So what we need to do is to let 1 plus x to be equal to tan theta. So let 1 plus x to be equal to tan theta. So it means that dx is equal to sec squared theta d theta. So this integral becomes integral of, now dx is sec squared, so sec squared theta d theta. Then all of this divided by, into brackets, we said that 1 plus x is tan theta. So here is going to give us tan squared theta plus 1, all of this squared. So this is equal to sec squared theta d theta divided by 1 plus tan squared theta, or tan squared theta plus 1 is sec squared theta, all of this squared. If we do the division, then we are going to see that this sec squared theta will cancel one of the sec squared thetas here. So this is equal to integral of d theta divided by sec squared theta. This is the same as sec squared theta is 1 over cos squared theta. So 1 divided by cos squared theta is the same as integral of cos squared theta d theta. There's an identity for cos squared theta, which is half of, into brackets, 1 plus cos 2 theta d theta. So the integral becomes half integral of d theta plus half integral of cos 2 theta d theta. So here becomes theta over 2, then plus 1 over 4 sine 2 theta d theta plus c. But we said that 1 plus x is equal to tan theta. It means that theta is equal to tan inverse of 1 plus x. Here becomes theta is tan inverse of 1 plus x, but there is 1 over 2 here, so 1 over 2 tan inverse of 1 plus x plus 1 over 4 sine 2 into bracket tan inverse of 1 plus x bracket close plus c. So let me rewrite the final answer again. So it is half tan inverse of 1 plus x and plus 1 over 4 sine 2 into bracket tan inverse of 1 plus x bracket close plus c. So this is a final answer for that integral.